I'm Erfan Nourbakhsh from UC Davis, and I want to introduce the workflow management system that I use for my PhD project. So I don't have time to go through the details of my actual project. Here, maybe I can take advantage of this time to just give a brief introduction to this workflow management system. So I'll give you a brief introduction to the job schedulers, and also I introduce the one that I use for my project, and that deals with a lot of the data. So you might be familiar with the basic cron job schedulers in Linux, for which we have different tasks that we run them at different times, but it is blind about the dependencies of the jobs that we have. So when that thing happens, something bad might happen, and here is a meme that you can see. So you might be using cron jobs for your data pipelines, but we want to avoid the cons of this method, for which it is a wise thing to pick a serious workflow management system. And by a serious workflow management system, I mean it should have smart scheduling and scalability, especially for the works that deal with a large amount of data. And maybe on top of that, you need to do some high performance computing as well. So by a smart scheduling, I mean you schedule tasks, of course, at different times. You have different tasks at different times, but also you want the task execution to be more data aware of the data that you have. And by scalability, I mean not only it should address the current data processing needs that you have, it also should be scalable with the future growth of your data, which means it should be without requiring substantial engineering time and infrastructure changes. So a lot of workflow management systems that they're out there in the market for big data pipelines, they usually do something called ETL, extract, transform, and load. But if you want to use a workflow management system, your project doesn't have to be a ETL process. So for myself, it wasn't quite like an ETL process. So there are different kinds of job schedulers. Of course, the CRON is not the solution. That's why I crossed it out. So we have Luigi, Azkaban. You might. So you've heard of Pinterest. So they made their own job schedulers. Pinball. Luigi, I believe, is for Spotify. Azkaban, I think, is for LinkedIn. And the last one that I picked for my project is Apache Airflow, that is designed by Airbnb. That's why the name is Airflow. So it is a platform that you actually can program your job, all of your jobs that you have. You can, for your workflow, the workflow itself is a program, it's a code. So it is developed by Airbnb, as I said, in 2014, and then it joined Apache Foundation in 2016, so it's pretty new. And it's built to the scale. It takes advantage of Python scripts, so it makes it very easy, and Python is mature enough for designing workflow management systems. So it has an active development on GitHub. There are a lot of people, it's very popular. There are a lot of people that they are using it, and they are making it a better workflow management system. And it has a rich web UI, so you can actually see the big picture of your workflow through a web interface. And it's officially used by about 300 companies. When I say officially, are the ones that they actually said that officially that they are using the Airflow management system, workflow management system. So companies like Tesla, Twitter, Yahoo, PayPal, United Airlines, and there's a long list that they wouldn't fit here. So it has different components. Something Airflow is very upfront about is something which is called DAGs, directed acyclic graph, or DAG. So it means that when you have a job and you represent your workflow by using a graph, something like graph, you are not allowed to have cycles. So it should be directed and acyclic. So it takes advantage of different operators, like bash operators, SQL query, Spark operations, and so on. And you also can add different operators to it too. It's not just, they're natively supporting some operators, but you can add more and more. So it has different sensors, and by sensor I mean there are actually operators that wait for some events to happen. Like if you want one file to appear somewhere, and after that do something else, and so on. And tasks are actual jobs that we are going to run, which is the final component of this chain. So this is a very basic example of a DAG. So an actual DAG for a big data workflow is going to be huge. But here, just see a minimal example of it, in which we have different tasks, and we can change them in different configurations. And we can always edit our DAGs and rerun it again. So I'm going to walk you through the web UI of Airflow. Here you can see a list of different DAGs that you have. If you design different DAGs, they appear on the first page on the web UI of Airflow. And you can turn them on and off, and you can run them on different schedules, daily, monthly. If you have to do something like on a regular basis, you can give it the frequency of it, and it can run them for you. Here also, the Airflow visualizes your DAGs for you. So you can author the DAGs in Python. So there are some old methods that people were using. They needed to bundle many XML files to do this. Now it's possible through Airflow with DAGs in Python. And also the tree view offers a view of DAG runs over time. You can see all of them in one picture. Also the Gantt charts, they reveal the slowest task for a run. Like here you see which tasks are running slower, and you can have some idea about your workflow in a visual way. So when it comes to HPC, or high performance computing, Airflow has Apache Spark integration already in it. And also, if you're using something else that requires having job schedulers like Slurm on a cluster, it does not support it natively. So, for example, for my project, I had to write it myself. And I have the Slurm integration to my Apache Airflow. So just very quick example of how it works. So in Airflow, you can have the log, the output of all of the jobs that you run. Like if there is a text output to it, you can have that. So I added that to the Slurm integration too. So for example, if you're familiar with Slurm job schedulers, when you run something, you can have two files, error file and output file. And here, because I'm lazy, I don't want to go log in and see my output files to see if a job has finished successfully. I want to see them through the web UI. So you can have that here by just having your .out file and .err file from Slurm without even needing to logging in. So, and the conclusion, I think is 10 minutes, right? Is try it out and see if it works for you. Thank you.